Welcome to myprojectbazaar.com. Most memory devices store and retrieve data by addressing specific memory location. As a result, this path often becomes the limited factor of the system that rely on fast memory access. The time required to store an item in memory can be reduced considerably if the time can be identified for access by this content rather than by its address. A memory that is accessed in this way is called content addressable memory as CAM. To achieve the effective function of data searching, the data comparison architecture of CAM is usually implemented in parallel operation structure. However, due to parallel process characteristic, power consumption is always an important concern while designing the CAM circuitry. That is, content addressable memories simultaneously compare an input word to all the contents of the memory and return the addresses of matching location in a single clock cycle. For example, consider a CAM consists of 4 words with each word containing 3 bits arranged horizontally. There is a matching line corresponding to each word feeding into matched line sensing amplifier, and there is a differential search line pair considering to each bit of the search word. A CAM searching operation begins with loading the search data word into the search data register, followed by pre-charging all matched lines high, putting them all temporarily in the matched state. Next, the searching line drives broadcast the search word onto the differential search lines, and each CAM core cell compares its storage bit against the bit on its corresponding search lines. Match lines on which all bits match remain in the pre-charged high state. Match lines that have at least one bit that misses discharge to ground. The MLSA then detects whether its match line has a matching or miss condition. Finally, the encoder matches the matched line of the matching location to its encoded address. In this project, we reduce the total amount of word length to reduce searching of overall database from the memory address. Here, the ML sensing amplifiers compares the power line for each and every word bits. Once if the power level exceeds the threshold level, the overall power for that line will be turned off. This will make the reduction of power losses in CAM memory. Further process, here there is a feedback loop to the ML sensing amplifier which employed to auto turn off the power supply, and hence it reduces the average power consumption by up to 64%. Now I am going to explain flow diagram of our project. In the first step of my flow, we give the input parallel bits. After that, we extract parity bit for the given input. This parity can be extracted for total database addresses and also for the given input 8-bit vector. The parity of the content saves us here indexes for the addresses. From the parity bits, we can easily extract and reduce the total amounts of database for the searching process. This may reduces the power losses for overall database search. After we extracting parity bit for the both database and for given input addresses, we first check the parity matchings for the database which are matching to input parity. After that, these parity extracted data are made as a separate database. This will reduce the overall database to our minimum states. In these parallel working cases, the ML sensing also checking the conditions whether the given total database is matching to threshold level or not. If the ML sensing amplifier checks the power losses which are made to high, then this will block the power flow for the total address line. Else, the searching was going for the total searching result. Then finally, we extract the search result. In the result case, if the ML sensing power is getting high, then we extracted output will be set to 0. Yes, we can got the extracted search result from CAM address. Now I am going to explain the running procedure of our project. Now just to open the cam.vsd file. After that, I first use the RTL schematic diagram by select implementation radio button and then run view RTL schematic by right click it in and click run button option. This will first check the errors and warnings in console window. If there are any errors or warnings, this will be displayed in the console window. This is also checking the total numbers of LUTs and flip-flop numbers which are presented in the logical designs. The RTL schematic design will display only the schematic architectures of logical operations which are provided in the codings. In this case, just click Add and click Create Schematic button. This is our overall schematic diagram. In this stage, our inputs are CAM new address, CAM enable and clock. The output pins are data output and parity addresses. Data out pin gets the data output which are search result from CAM register. The parity is displaying the given input image parity. After that, we can view the internal structure of RTL schematic by double click it. This is our overall internal circuits. This is the bird line which are generated at the output pins. Then we can display the technology schematic diagram by right click it and click run option. Click add and click create schematic. This is our technology schematic diagram. This will display as a LUTs and flip-flop structures. For each and every lines, this will be provided as a buffer. Then, now we can view the timing diagrams of the output by selecting simulation option and select our main coding. Then click simulate behavioral model. This provides the timing diagrams for logical designs. In this case, it will create a GUI. Here I am using iSim technology for visualizing our outputs. In the first stage, we give the clock signal as set to 0. In the first value, I giving the input as 0. Then I give the CAM enable as 1 by right click it in and force constant and force to value and set as 1. After that, I give the input address by right click it in and force constant and enter the address. Then click the run for time specified on the toolbar. This will generate the CAM addresses which are matching to parity values. The addresses will be matching to this, and finally we extract parity search result and data output. The data output will be generated as relevancies for the search result from CAM addresses. The check bit is displaying the parity address for the given input database. In this, the pair out will display the parities for each and every database addresses. in CAM register. This is our overall flow. Thus we extract the matched result from CAM register. Thank you.